to this video of if you want to feel something, become an electrician. And then I'm going to explain to you exactly what's going
We're
on.
electricians. We ain't got time to shut down no disconnects. A little bit of a load on it. There you go. Got to forge ahead. Get that underneath there. Gonna hurt you. Wear your gloves. You'll be all right.
So I've watched this so many times now that I've become desensitized to it. But basically what you see here is an arc flash. So this is a electrical meter. It looks like it's probably outside someone's house. And the way it works is this is single phase 2-pole power coming in from the utility, either underground or from a pole, and it crosses through the meter and then back out, and then from here it goes to the customer's electrical panel. Now the reason that they have the reason it looks like they're probably replacing these wires. So sometimes if the power supply, if the service, let's say the service is 100 amps, which is pretty typical for a house, sometimes the customer is adding things like a car charger or whatever, and then they need more power, so they want to upgrade. And when they do that, they have to replace possibly the meter, possibly the wires, because the wires might not be thick enough. And so sometimes in residential, they're in a hurry and they don't do things safely, so they do everything live. Now, there's no breaker here, so how do you shut the power off when you want to change a wire? Well, you have to, you could either remove this meter, so you could typically, this is locked so that you can't tamper with it, but you can call the power company and they can take it off. But the other thing that we should look at here is this is typically your setup. So you've got a power line coming in from the utility, goes to the meter, and then it goes to your electrical panel, and there's a main breaker, and then all of these are like vacuums, if you can think of it. Like they're all sucking power in the house from each breaker. So you've got receptacles which could have like stove or whatever kind of appliances. And so as soon as you bring this wire here, you see we've got this wire here, and the end of it is frayed, and we're bringing it really close to the lug in the video. So as soon as that happens, since there's so much power being drawn from the devices, as soon as we get close, the electricity starts to jump onto the wire. But the thing is, the tip of the wire is so thin that it can't handle all that power, and so this jump creates a flash, and it gets extremely hot, and it melts the copper in the wire, and it ignites the air around it, and you get the flash, which is extremely dangerous. So you can avoid this and still do it live if you shut all these breakers off. So if you shut all these breakers off, you're not going to have much of a, it's still dangerous to do, mind you, but you're not going to have much of an arc flash because there's nothing drawing the power like there is now. So he didn't do that, and he just went and did it again. And this is extremely dangerous, not just because of the arc flash, but there's also potential, say if this wire was damaged here, let's say there was a damage to the insulation and there was some exposed metal and he touched it, he could have died right there. Or if the wire made contact with the box that it's in while he's working in this electrical box, and so if some of this wire got frayed and touched the metal, and he is touching the metal with one of his hands, then he could also have gotten electrocuted. So there's so many different things that could go wrong here. It's just crazy to do it like that. So if you have any questions, please post a comment. Thank you.